Note also, another important thing is that even though you have different substances, all of those will have the same features in the phase diagram. They have this triple point, they have the critical point, they will have the equilibrium lines, okay? The only difference in this case is the actual location, the actual conditions of pressure and temperature that each of those points have, okay? But they have the same features. Now, think about water. Let's now go read water. If we're talking about normal, that normal refers to 1 atmosphere of pressure. 1 atmosphere of pressure, you keep the pressure constant, and because we're talking about boiling point, that refers to the coexistence of the liquid and the gas in that transition. So 1 atmosphere of pressure, once you hit this equilibrium line, then you go and read the temperature that corresponds. So that's going to be 100 Celsius. Now, normal fusion point, because it's fusion, you're going to be talking about the transition between the solid and the liquid. Because it's normal, you're going to look at 1 atmosphere of pressure. You keep the pressure constant. Once you reach the equilibrium line for this transition, you go ahead and read what is the temperature that corresponds to that, and in this case it's going to be 0 Celsius. Now note that whenever we're talking about sublimation, for the case of water, we're not using the term normal, because at 1 atmosphere of pressure, the two transitions that you can have is solid to liquid, liquid to gas, but you cannot have the transition solid to gas that corresponds to the sublimation. That can only happen below 1 atmosphere of pressure. And actually, it can happen only below the conditions for the triple point. So only below this pressure of 0.06 atmospheres. But now the temperature of sublimation, remember, is going to be any temperature that corresponds to the points that belong to this equilibrium line. So the temperature of sublimation can be any temperature that can be located in this region. Now the real question for this one is, if you tell me what pressure you want me to locate, then I can tell you what is the temperature that corresponds to that pressure. Then this problem, the sublimation temperature, can only be referred to a specific pressure. Otherwise, it's ambiguous because it can be any, basically any temperature that it's located in this region. If that is the case, again, you always have to ask at what condition of pressure. Another thing that is very interesting about water, look at this slope. This slope is negative. Let's go back to these other substances. This is very steep, but it's positive. Very steep, but it's positive. Look at this one, very steep and negative. That's a huge difference between between water and other substances. So let's look at this. Again, you have this slope that it's looking at the transition between the solid and the liquid. This slope here, the slope, it's actually the rate of change between the pressure and the temperature. Okay, that's how we define the slope. And then according to the experimental measurements, that slope is negative. Okay. Now, I'm not going to tell you about how to derive this expression, but for the purpose of our explanation, that it's actually coming from thermodynamics. Now, we know that in this transition solid to liquid, that is an endothermic reaction or endothermic process. So this is going to be positive. The temperature is also positive in the absolute scale. Now, in order to make, if this is positive and positive, in order to make the slope negative, then this one has to be negative. And that delta V is the volume of the solid going to the volume of the liquid. Is going to be the volume of the liquid minus the volume of the solid. that has to be negative. And that can only be negative if this, the volume of the solid, is larger than the volume of the liquid. That's actually very interesting, because now if you look at the definition of density, density equals mass over volume. Volume is inversely proportional to the density. So if this is bigger, then that means its density now it's going to be smaller. Okay? Oop. The density of the solid and the density of the liquid. Now that means that the solid water is less dense than liquid water, so that ice actually floats on the liquid water. It floats. We know that. We can get that information from this phase diagram. We know that ice floats, and it's very relevant, particularly when you think about rivers and lakes, because in the winter water freezes, but it always freezes from top to down. Okay, so the top is frozen, it protects, insulates the water beneath that, allowing to fish to be alive even if part of the rivers is already frozen.